Let's debrief the clock digits problem. So remember, here's our problem. So we've got 12-hour clock. How many times are they displayed in increasing order? The things to understand here were really varied. First, you needed to see that we were talking about just digits. So digits are 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, not things like 9, 10. Consecutive means immediately following, so not like 8 and then 0, 9. It has to be right in a row. My classes reminded me you had to know how time works here. You can't have 67 or 78 in the minutes place. And also what digital clocks look like and kind of how they work. And then I had a couple students miss increasing and did decreasing as well. The heuristic I used was just make an organized list. So if you haven't checked out that video, please feel free to do so to see how I did it. And that's what I mostly got from students, was making an organized list or table. I got lots and lots of different tables and lists. Basically, everybody gave me a list or table, and that's how they said they did it. I had a few people use guess and check, and that's a little bit harder because jumping around is not quite as easy to do for this one as it is to do just making a list that's in an order. So remember, our last step of Polya's problem-solving process is always to look back and examine the answer. Can you check your result? Does your result make sense? Can you check your argument? Could you get there a different way? Could you see your solution at a glance? For this one, this is really hard. Because almost everybody made an organized list, it's hard to come up with another way to think about this or another way to do it. Even guess and check is really similar to making your organized list because you're doing the same thing for both. You're just making out your list, you're making out what organized or what guesses make sense, and you end up with that same list. I thought of another way to approach this, and I was glad to see one student tried this method, but they unfortunately missed one. Since all of the times are increasing digits, we could just look at a list of the digits. All my times should be here somewhere if they're correct times. So for example, here's 123, 234, 345, 456, and then we can see quickly that 567 and these other two don't work. The hard part about using this, which is I think using manipulatives, because really I'm manipulating pieces, I'm moving stuff around. It's really easy to miss 1234 if you do this method. So you've got to remember not just look at 3-digit times, but 4-digit times. But then you can see 2345 doesn't work for our 12-hour clock. Our last thing is always, can you use this result on method on other problems? Have you learned anything new? Here's a couple problems you could try if you wanted. What if instead of doing digits, we did increasing numbers? So what if we also accepted the time 9, 10? How many times would we have increasing numbers in a 24-hour period? What if we did military time with single digits? And you actually need to know some things before you start here. So if you wanted to try this for military time is a 24-hour clock. So it goes from 00, which is midnight, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then all the way up to 23. So 23 is 11 p.m., 23:59 would be 11:59, and then that rolls over to 0000, which is midnight again. Also, you need to know if you're going to do this for military time. Military times are always 4 digits. So say 3:45 a.m., it's actually 0345. So that would not be an increasing one. If we had a display that just showed those 5 times from the original questions that worked, would it light up all the diodes in the ones digit? So by that I mean, if you look at a digital clock, all the numbers are made up with 7 diodes, 7 little pieces of the number that can light up. If we lit up all the times, 123, 234, and so on, would we light up all the diodes in the ones digit? Would we light up all the diodes in the hours digit? Okay, there's a lot of cool stuff you can think about with clocks and diodes and how we represent the numbers kind of related to this question that aren't directly related, but definitely are on the fringe there that you could look into.